Determine dy by dx for the function square root of x plus square root of y equals to 1. So let's find derivative with respect to x on both the sides. So we get d dx of square root of x plus d dx of square root of y equals to d dx of 1, correct? Now d dx of square root of x is 1 over 2 square root x. D dx of square root of y is 1 over 2 square root y dy dx. And derivative of 1 is 0. Now how did I get this? So let me show you derivative of square root of y here on the side so that this step is very clear to you, and then I'll continue, right? So let me show you this part. So we did d dx of square root of y, which is y to the power of half, correct? Now we'll apply chain rule here. So this is equal to d of dy of y to the power of half times dy dx, right? Now what is the derivative of y to the power of half with respect to y? It is half y to the power of half minus 1. Let me write half minus 1, and we have times dy dx. Now half minus 1 is minus half, so we get half times y to the power of minus half dy dx, correct? Which is what I wrote, that is 1 over 2 square root y dy dx, correct? So that is how you get it. So I didn't really show all these steps, but I know by now you know it, right? But I thought let me just summarize it. So this is how I did that part, and you know this was derivative with respect to x, so I would have got this part, right? Now here we can isolate dy dx, so that means 1 over 2 square root y dy dx is equals to minus 1 over 2 square root of x. Now from here we can simplify and get dy dx equals to minus square root of y over square root of x, or minus square root y over x. So that is our solution for the given equation. Now as an added exercise, I would like you to find equation of a tangent at any given point on this curve. So you can take points as x equals to 1 or some other value, whichever you think is good enough, right?